Hello dear students, in this video we will see the previous year questions and questions from sample papers from the two chapters, chapter 3b and chapter 3c, which are integration and its applications and differential equations. So here we have the questions from last year's board paper. Evaluate integral 0 to 1 x e raised to x upon x plus 1 the whole square dx. So here let I be the given integral. Let I is equal to integral 0 to 1 x e raised to x upon x plus 1 the whole square dx. So in the numerator let us add and subtract 1. So this is nothing but integral 0 to 1 x plus 1 by x plus 1 the whole square minus 1 by x plus 1 the whole square into e raised to x dx. So this will go. So it is integral 0 to 1 by x plus 1 minus 1 by x plus 1 the whole square into e raised to x dx. Here we can see that if we take this as f of x, then the derivative of 1 by x plus 1 is minus 1 by x plus 1 the whole square. So this is of the form integral f of x plus f dash of x into e raised to x dx. So for that we have the standard result. We can use that standard result and find the answer. Here f of x is equal to 1 by x plus 1 and f dash of x is equal to minus 1 by x plus 1 the whole square. Therefore, I is equal to e raised to x into f of x, that is 1 by x plus 1 with the limits 0 to 1. Since integral e raised to x into f of x plus f dash of x dx is equal to e raised to x into f of x plus c. We are aware of this standard result, so that result we are using it here. Here f of x is 1 by x plus 1 and f dash of x is minus 1 by x plus 1 the whole square. So we have this integral as e raised to x upon x plus 1 with the limits 0 to 1. So if we substitute the upper limit, it is e raised to 1 by 1 plus 1. So it is e by 2 minus if we substitute the lower limit, it is e raised to 0 by 0 plus 1, which is 1. Therefore, the value of the given integral is e by 2 minus 1. So this question carries 2 marks. Next question, if the marginal revenue function for output x is given by marginal revenue equal to 6 by x plus 2 the whole square plus 5, find the total revenue function. So this is a very easy question. Marginal revenue is given, we have to find the total revenue. We know that total revenue is integral of marginal revenue. Given marginal revenue is 6 by x plus 2 the whole square plus 5. So total revenue is integral of the marginal revenue function. So it is integral 6 by x plus 2 the whole square plus 5 dx. So integral of 6 by x plus 2 the whole square is 6 into x plus 2 the whole raised to minus 2 plus 1 by minus 2 plus 1 plus 5 into integral dx is x plus c. So here it is x plus 2 whole raised to minus 1. So it is 1 by x plus 2 and here it is minus 1. So this is minus 6 upon x plus 2 plus 5x plus c. Now we know that when the level of output is 0, total revenue equal to 0. From this, here total revenue is 0 when x is 0. So we have 0 equal to minus 6 by 0 plus 2, it is 2 plus 0 plus c. So from this we get c equal to 3. Therefore, the total revenue function is given by minus 6 by x plus 2 or 5x minus 6 by x plus 2 plus 3. So this is the total revenue function. This is the total revenue function. Again, this question carries 2 marks. Moving on to the next question. Evaluate integral 0 to 4 mod x minus 2 dx. This is also a 2-mark question. So here we have a modulus function, that is definite integral of modulus function. These are very important questions. Here if we consider this mod of x minus 2, if we put x minus 2 equal to 0, we get x as 2. So if we have the interval from 0 to 4, from 0 to 2, we have this x minus 2 as negative, and from 2 to 4, this x minus 2 is positive. So we can write the given integral as, let us first take, let I be the given integral. So this is equal to integral 0 to 2 mod x minus 2 dx plus integral 2 to 4 mod x minus 2 dx. Here we have to write why we have written this, that is using the result. Since integral a to b f of x dx equal to integral a to c f of x dx plus integral c to b f of x dx, where b is in the interval a to c. So using this property of definite integral, we are writing this. This is in the rough. So this implies I is equal to, in this interval, in the interval 0 to 2, we have x minus 2 negative. So it is negative in the interval 0 to 2. So it is integral 0 to 2 minus of x minus 2 dx. Then in the interval 2 to 4, this is positive. Integral 2 to 4 x minus 2 dx. We cannot directly integrate modulus function, so we have to remove the modulus sign by dividing the entire interval into the intervals where it is positive and negative. Accordingly, we have to write the functions. So here this is integral x minus 2 dx is x minus 2 the whole square by 2 with the limits 0 to 2 plus x minus 2 the whole square by 2 with the limits 2 to 4. So here when we substitute the upper limit, it is 0 minus, when we put the lower limit, it is 0 minus 2 the whole square 4 by 2, which is 2, plus here when we substitute the upper limit, it is 4 minus 2 the whole square, 2 square, which is 4, divided by 2 is 2. When we put the lower limit, it is 2 minus 2, 0. So this is 2 plus 2, which is 4. Therefore I equal to 4. Therefore the value of this given integral is equal to 4. Next question, solve the following differential equation: dy by dx equal to e raised to x plus y plus x square e raised to y. So let us solve this differential equation. Again, this is also for 2 marks. Dy by dx equal to this e raised to x plus y, we can write it as e raised to x into e raised to y plus x square e raised to y. Here e raised to y is common, which can be taken outside. So inside the bracket we have e raised to x plus x square. This is dy by dx. From this we get dy by e raised to y equal to e raised to x plus x square dx. Now we can integrate on both sides. On integrating, integral this dy by e raised to, we can write it as e raised to minus y dy equal to integral e raised to x plus x square dx. Implies integral e raised to minus y dy is minus e raised to minus y. This is equal to integral e raised to x is e raised to x. Integral x square is x cube by 3 plus c. So we can bring this e raised to y to one side. So that we will have 0 equal to e raised to minus 5 plus e raised to x plus x cube by 3 plus c, or e raised to minus 5 plus e raised to x plus x cube by 3 plus c equal to 0 is the required solution. Next question, the supply function of a commodity is 100p equal to x plus 2 the whole square. Find the producer surplus when market price is rupees 25. So here we have to find, it is a question for 3 marks. So here we have to find the producer surplus when the market price is rupees 25. So here P naught is given as rupees 25. The supply function is given by supply function is 100p equal to x plus 20 the whole square. So we usually write supply function as p equal to some function of x. So here p equal to x plus 20 the whole square upon 100. Now substituting p naught equal to rupees 25 in, let us take this as 1, in 1. We get 25 equal to x plus 20 the whole square upon 100, or we get 2500 equal to x plus 20 the whole square. That is x plus 20 the whole square is 2500. So if we take root on both sides, we get x plus 20 equal to root of 2500 is 50. So it is plus or minus 50. So from this we have x plus 20 equal to 50 implies x is equal to 30, or x plus 20 equal to minus 50 implies x is equal to minus 70. This is not possible. Therefore, x naught equal to 30. So this is x naught equal to 30 units. So here finding the value of x naught carries 1 mark. Now we can find the producer surplus. Producer surplus is equal to p naught x naught minus integral 0 to x naught supply function dx. P naught is given, it is 25. So 25 into 30 minus, this is the supply function, 1 by 100 into integral 0 to x naught is 30, x plus 20 the whole square dx. So this is 750 minus 1 by 100 into integral of x plus 20 the whole square is x plus 20 the whole cube by 3 with the limits 0 to 30. This is 750 minus 1 by 300 into, here we have 30 plus 20 which is 50, 50 the whole cube, it is 1,25,000 minus lower limit is 0, 0 plus 20, 20 the whole cube, it is 8,000. So this is 750 minus 1,17,000 divided by 300. So this is 750 minus 390 which is 360. Therefore, producer surplus is 360 units. So this is the producer surplus. So here, as I already mentioned, finding x naught carries 1 mark. Then writing the formula for producer surplus and substituting the values carries 1 mark. Remaining steps and the final answer carries 1 mark. A total of 3 marks for this question. Next question, integral 2x square plus 1 upon x square minus 3x plus 2. Again we have this question for 3 marks. So here we have to find the integral of this function. So here let us take, let the given integral be I. Let I equal to integral 2x square plus 1 upon x square minus 3x plus 2 into dx. So here the degree of numerator and the denominator are the same. So this is an improper rational function. Let us do long division to find the quotient and remainder. So 2x square plus 1 divided by x square minus 3x plus 2. So when we multiply this by 2, it is 2x square minus 6x plus 4. So this when we subtract, you will get 0 plus 6x minus 3. So this becomes integral quotient. Quotient is 2. 2 plus remainder is 6x minus 3 upon the divisor. X square minus 3x plus 2 dx. So this is integral 2 plus 6x minus 3 upon. This we can factorize. X square minus 3x plus 2, it is x minus 2 into x minus 1 upon x minus 2 into x minus 1 into dx. Now we can find integral 2 dx easily, but to integrate this we have to use partial fractions. So let us take, let 6x minus 3 upon x minus 2 into x minus 1 equal to a by x minus 2 plus b by x minus 1. So from this we get 6x minus 3 as a into x minus 1 plus b into x minus 2. So here it will be a plus b into x plus minus a minus 2b. The left hand side we have 6x minus 3. So here all these are in the rough. We can equate the coefficient of x and constant term on both sides. A plus b equal to 6 and minus a minus 2b equal to minus 3. When we add these two, we will get minus b equal to 3 or b equal to minus 3. If we put b as minus 3 here, we will get a minus 3 equal to 6, a equal to 9. Therefore, the given integral becomes integral 2 plus, in place of this 6x minus 3 by x minus 2 into x minus 1, we have a by x minus 2, we got a as 9, so it is 9 by x minus 2 and b as minus 3. Minus 3 by x minus 1 dx. Now we can integrate this easily. Integral 2 dx is 2x plus integral dx by x minus 2 is log mod x minus 2 minus 3. Integral dx by x minus 1 is log mod x minus 1 plus c. So this is the integral of this function. Next question, the demand and supply functions for a commodity are, this is the demand function 56 minus x square and supply function is 8 plus x square by 3. Find the consumer surplus at equilibrium price. So here we have to find the consumer surplus at equilibrium price. We know that at the equilibrium, the quantity demanded is equal to quantity supplied and the corresponding price is also equal. So using that we can find the equilibrium quantity and then we can find consumer surplus at equilibrium price. At equilibrium, PD equal to PS. implies 56 minus x square equal to 8 plus x square by 3, or 48 equal to x square by 3 plus x square. So this, when we take LCM, we get 4x square by 3. So 48 into 3 by 4 equal to x square. So from this we get x square equal to 36, or x is equal to plus or minus 6. Since we cannot have the level of output as negative, therefore we get x naught as 6. So the equilibrium quantity is 6. We can substitute this in the demand function to find the equilibrium price. Substituting x naught equal to 6 in PD equal to 56 minus x square, we get P naught equal to 56 minus 36, which is 20. Therefore, P naught equal to rupees 20, and x naught is 6 units. So here we are asked to find consumer surplus. So for consumer surplus, we have to use the right formula, integral 0 to x naught demand function minus P naught x naught. So we should not get confused with the demand function and the supply function. If we are finding consumer surplus, we have to use the demand function. If we are finding producer surplus, then we have to use the supply function. Here for consumer surplus, the formula is integral 0 to x naught demand function dx minus P naught x naught. So here we got x naught, it is integral 0 to 6. Demand function is 56 minus x square dx minus P naught x naught. So here P naught is 20 and x naught is 6. So this is integral 56 dx is 56x minus integral x square is x cube by 3 with the limits 0 to 6 minus 120. So here 56 into 6, it is 336 minus 6 cube by 3, 72 minus 120. So this is equal to 144. Therefore consumer surplus, it is equal to 144 units. So here finding x naught, it carries 1.5 marks. The remaining steps, writing the formula and the final answer, carries 1.5 marks. Next question, integral 0 to 1 log 1 plus 2x dx. So here let us take, let I equal to integral 0 to 1 log 1 plus 2x dx. So let us make the substitution so that it will be easy. Put t equal to 1 plus 2x. From this we get dt equal to 2 dx or dt by 2 equal to dx. So when x equal to 0, t equal to 1, when x equal to 1, t equal to, here we are putting 1 plus 2, it is 3. So the given integral becomes integral 1 to 3 half log t dt. So in place of 1 plus x we are putting t, and in place of dx we are putting half dt, and we have changed the limits to 1 to 3. Now we can use integration by parts to find the integral of this function. So here we can take log t as the first function and 1 as the second function. So using integration by parts, So here the given integral becomes first function, that is log t, into integral of the second function, that is integral 1 into dt, which is t. So it is log t into t with the limits 1 to 3. There is 1/2 outside. Minus integral 1 to 3, derivative of the first function, derivative of log t is 1 by t, into integral of the second function, which is t dt. So this is half into, if we substitute the upper limit, it is 3 log t, 3 log 3, minus when we substitute the lower limit, it is 1 into log 1, which is 0, minus here it is integral dt, which is t, with the limits 1 to 3. So this is half into 3 log 3, minus upper limit is 3, lower limit is 1. So it is 3 minus 1. So this is half of 3 log 3 minus 2, or it is 3 by 2 log 3 minus 1. So this is the value of this given integral. And this question also carries 3 marks. Moving on to the next question. A question from differential equation which was asked in last year's board paper. In a certain culture of bacteria, the rate of increase of bacteria is proportional to the number present. It is found that there are 10,000 bacteria at the end of 3 hours and 40,000 bacteria at the end of 5 hours. Determine the number of bacteria present in the beginning. So here they have given the rate of increase of bacteria is proportional to the number present. So it is population growth model. And they have given at the end of 3 hours there are 10,000 bacteria, and at the end of 5 hours there are 40,000 bacteria. We have to find the number of bacteria which is present at the beginning. So here let us take, let P of t be the population of the bacteria at any time t. First we have to derive the population growth model. Here it is given the rate of increase of bacteria is proportional to the number present. So deriving the model carries 2 marks. Given dp by dt, it is proportional to p. So from this we have dp by dt, it is equal to some constant of proportionality k into p. From this we can write dp by p. We can solve this differential equation. It is equal to k into dt. Let us integrate both sides. We get log p equal to kt plus c. Now this is log p to the base e. From this we get p equal to e raised to kt plus c, or p equal to e raised to kt into e raised to c. Now let us take when t equal to 0, let us take p equal to lambda. So from this we get lambda equal to e raised to 0 into e raised to c. As a result we get e raised to c as lambda. Therefore p equal to lambda e raised to kt. So this is the required model. Deriving this model carries 2 marks. And then it is given there are 10,000 bacteria at the end of 3 hours and 40,000 bacteria at the end of 5 hours. P of 3 equal to 10,000 implies 10,000 equal to lambda into e raised to 3k. And from here we have P of 5 equal to 40,000 implies 40,000 equal to lambda into e raised to 5k. So let us take this as 2 and this as 3. Now let us divide 3 by 2. Divide 3 by 2. We get 40,000 by 10,000 equal to lambda into e raised to 5k upon lambda into e raised to 3k. So from this we get 4 equal to lambda into e raised to 5k minus 3k. So it is e raised to 2k. So this e raised to 2k we can write it as e raised to k the whole square it is equal to 2 square. So from this we get e raised to k equal to 2. Let us take this as 4. Now we have to determine the number of bacteria present in the beginning. That is, we have to find lambda. From 2, we have 10,000 equal to lambda into e raised to 3k. We can write it as e raised to k the whole cube. Or we get 10,000 equal to lambda into 2 cube. From this we can see that lambda is equal to 10,000 divided by 8. So it is 1250. So the number of bacteria present in the beginning is 1250. Therefore 1250 bacteria were present initially. Were present in the beginning. So this is the answer. After this, finding a relation for k, all these steps up to here will carry 1 mark, and then the remaining steps and the final answer carries 1 mark. So here derivation 2 marks, then the remaining steps 2 mark, a total of 4 marks for this question. Moving on, next question. It is known that if the interest is compounded continuously, the principal changes at the rate equal to the product of rate of bank interest per annum and the principal. So using this, we have to find the answer for these two. If the interest is compounded continuously at 5% per annum, in how many years will rupees 100 double? And then at what rate of interest will rupees 100 double itself in 10 years? So we have to find the answer for these two. So this is compound interest. So let us take, let A be the amount at any time t and R be the rate of interest per annum. Here it is given dA by dt, it is equal to R into A. From this we have dA by A equal to R into dt. Let us integrate both sides. We get log A equal to RT plus C. Or we have A equal to e raised to RT into e raised to C. So let us take a t equal to 0, that is the principal amount which is deposited at the beginning. Let A equal to A naught implies A naught equal to e raised to C. Therefore, A equal to A naught e raised to RT. So this is the required model. Now using this, let us find the answer for these two questions. The first question, if interest is compounded continuously at 5% per annum, in how many years will rupees 100 double? So the first subdivision, A naught is 100, that is A will be 200 and R is 5%, it is 0.05. So let us substitute all these in 1. From 1 we have 200 equal to 100 into e raised to 0.05 t. Let us take log on both sides. Log 2 to the base e, it is equal to this log e raised to 0.05 t, it is 0.05 t log e. This log e is, it is log e to the base e, so it is 1. As a result, log 2 to the base e, it is equal to 0.05 t log e. This is log e to the base e, which is 1, and we have log 2 to the base e given here, it is 0.6931. From this 0.6931, it is equal to 0.05 t, or t equal to 0.6931 divided by 0.05. It is 69.31 divided by 5. From this we get t as 13.86 years. So the Time period in which rupees 100 will double when the rate of interest is compounded continuously at 5% per annum. It is 13.86 years. The next subdivision, at what interest rate will rupees 100 double in 10 years? So if we want to know the rate of interest at which rupees 100 will double itself in 10 years, then here again A0 is 100, A is 200, and here time is given as 10 years. We have to find R. From 1, 200 equal to 100 into e raised to 10 R. So again let us take log on both sides. Log 2 to the base e. It is log e raised to 10 R. It is 10 R log e. Now this log e is 1 and log 2 to the base e, the value is given here. It is 0.6931. This is equal to 10 R, or R is equal to 0.6931 divided by 10. It is 0.06931. Usually R is represented in percentage. Therefore, R is equal to 6.931%. So, when the rate of interest is 6.931%, rupees 100 will double itself in 10 years. So, these are the answers. This question also carries 4 marks. Now, we will see the questions from last year's sample question paper. The marginal revenue function for a commodity is given by marginal revenue equal to 9 plus 2x minus 6x square. Find the demand function. So, this is a question for 2 marks. It's a very easy question. Here the marginal revenue is given. We have to find the total revenue and from that we can find the demand function. So, here marginal revenue is given as 9 plus 2x minus 6x square. So, from this we can find the total revenue as integral of this marginal revenue. So, it is 9 plus 2x minus 6x square dx. So, this when we integrate we get 9 integral dx is x plus 2 into integral x is x square by 2, then minus 6 into integral x square is x cube by 3. Plus the constant of integration c. So, it is 9x plus x square minus 2x cube plus c. So, this is the total revenue function, but we are having a constant c for which some value should be substituted. Now, we know when the level of output is 0, total revenue is 0. From this we get 0 equal to, when we put x as 0 here, all these will go and we will be left with c. Therefore, c is 0. Therefore, total revenue equal to 9x plus x square minus 2x cube. We know that total revenue is equal to demand function into x. So, p into x is equal to 9x plus x square minus 2x cube. Since total revenue equal to px. From this we get p equal to 9 plus x minus 2x square is the demand function. So, this is the demand function. So, here finding the total revenue function carries 1 mark and finding the demand function carries 1 mark. Next question, the marginal cost of producing x pairs of tennis shoes is given by marginal cost is equal to 50 plus 300 by x plus 1. If the fixed cost is rupees 2000, find the total cost function. So, here marginal cost is given, we have to find the total cost function. Here marginal cost equal to 50 plus 300 by x plus 1. So, from this we can find total cost as integral of marginal cost. So, it is integral 50 plus 300 by x plus 1 dx. Integral 50 dx is 50x plus 300 into integral dx by x plus 1 is log mod x plus 1 plus the constant c. So this is the total cost function, but we are having this C. Additional information which is given is fixed cost is 2000. That is when the level of output is 0. When x is equal to 0, the total cost is 2000. This implies 2000 equal to 50 into 0 plus 300 log 0 plus 1 is log 1 plus C. So this is 0, this is 0. From this we get C as 2000. Therefore, total cost equal to 50x plus 300 log mod x plus 1 plus C. So here integrating and finding this carries 1 mark. Then finding the value of constant of integration, and here C is 2000. And the final answer carries 1 mark. So this question also carries 2 marks. Next question, the supply function for a commodity is given by P equal to x square plus 4x plus 3, where x is the quantity supplied at price P. Find the producer surplus when the price of the commodity is rupees 48. So here the supply function is given, and then the price is given as rupees 48. We have to find the producer surplus at this price. P naught equal to 48, substituting P naught equal to 48 in P equal to x square plus 4x plus 3. We get 48 equal to x square plus 4x plus 3 implies x square plus 4x minus 45 equal to 0. So this is a quadratic equation in x. Here it is x square plus 9x minus 5x minus 45 equal to 0, or x into x plus 9 minus 5 into x plus 9 equal to 0. So x minus 5 into x plus 9 equal to 0. X is equal to 5 or x is equal to minus 9. Now this is not possible since the level of output cannot be negative. From this we get x naught is equal to 5 units. So we got P naught and we got x naught. Now we can find the producer surplus. The producer surplus, it is given by P naught x naught minus integral 0 to x naught supply function dx. So P naught is 48, x naught is 5 minus integral 0 to 5 x square plus 4x plus 3 dx. So this is 240 minus x cube by 3 plus 4x square by 2 plus 3x with the limits 0 to 5. So it is 240 minus x cube by 3, it is 125 by 3 plus here we have x square, 5 square into 2 which is 50 plus here we have 15 minus the lower limit is 0. So this is 240 minus 50 minus 15 minus 41.67. So this comes out to be 133.33. Therefore, producer surplus is 133.33 units. So this is the producer surplus. So here finding x naught carries 1 mark, then writing the formula, substituting the values carries 1 mark. Remaining steps and the final answer carries 1 mark. A total of 3 marks for this question. Now moving on to the next question. General anesthesia is used for major operations to cure the patients and conduct pain-free surgeries. Propofol is a commonly used anesthetic injected for major operations such as knee replacement or open heart surgery. It also acts as a sedative and analgesic. A patient is rushed to operation theatre for a 2-hour cardiac surgery. A person is anesthetized when its bloodstream contains at least 3 mg of propofol per kg of body weight. So this is all these are information about this drug propofol. The most important thing to be noted is only when there is at least 3 mg of propofol per kg of the body weight, the person will be anesthetized. The rate of change of propofol in the body is proportional to the quantity of propofol present at that time. Based on this, we have to answer these two questions. The first subdivision is we have to show that propofol given intravenously is eliminated exponentially from the patient's bloodstream. So this is the drug assimilation model that we have to derive. Then the second subdivision is what dose of propofol should be injected to induce unconsciousness in a 50 kg adult for 2 hours operation. So there is a similar question given as example in the CBSE handbook. We have to proceed in the same manner. So for deriving the model, it is given the rate of change of propofol. It is proportional to the quantity of propofol present at that time. So the first subdivision given dx by dt, it is proportional to x. So according to the drug assimilation model, over a period of time, the quantity of the drug, it decreases over time. As a result, we have dx by dt equal to minus kx, or we get dx by x equal to minus k dt. Now let us integrate both sides. Integral dx by x equal to minus integral k dt. So from this we get log x equal to minus kt plus the constant of integration c. This is log x to the base e. So we get x is equal to e raised to minus kt into e raised to c. Now let us take the initial amount of drug which is induced be x naught. So when t equal to 0, let x equal to x naught. From this we get x naught equal to e raised to 0 into e raised to c, or e raised to c equal to x naught. Therefore, the required model is x equal to x naught into e raised to minus kt. So this is the required model, which is the answer for the first subdivision. So here they have asked us to show that propofol given intravenously, it is eliminated exponentially from the patient's bloodstream. So it is eliminated exponentially from the patient's bloodstream. Now we'll move on to the second subdivision. What dose of propofol should be injected to induce unconsciousness in a, it is not 50 years, it is 50 kg adult. In a 50 kg adult for a 2 hours operation. So let us do this subdivision. Before that we have to find a relation for k. Here it is given, assume half-life of propofol is 5 hours. So here half-life of propofol is 5 hours, it is given. The meaning is that when t equal to 5 hours, x equal to x naught by 2. So from this we get x naught by 2 equal to x naught into e raised to minus 5k. So here x naught and x naught will go. If we cross multiply, we get e raised to plus 5k equal to 2. E raised to 5k is nothing but e raised to k the whole raised to 5 equal to 2, or from this we have e raised to k equal to 2 raised to 1 by 5. Let us take this as equation 2. So this is a relation for e raised to k. So here deriving the model carries 2 marks and finding a relation for k carries 1 mark. The remaining part and the final answer will carry 1 mark. Here we have to find the amount of the drug which should be injected to induce unconsciousness in a 50 kg adult. So the important information given is there should be at least 3 mg of propofol per kg of body weight. So for a 50 kg adult, at the end of 2 hours, the adult should have at least 3 into 50 mg of the drug. So it is equal to 150 mg. So when t equal to 2 hours, x equal to 150 mg, we have to find x naught. We have 150 equal to x naught into e raised to minus 2k. Or from this we get x naught is equal to 150 into e raised to 2k. Here if we cross multiply this, when it goes to the other side, it becomes e raised to plus 2k. So it is 150 into e raised to k the whole square. Now we already know what is e raised to k. It is 2 raised to 1 by 5. So it is 2 raised to 1 by 5 the whole square. This is from 2. Now the value for 2 raised to 1 by 5 is given here. It is 1.1487. So it is 150 into 1.1487 the whole square. Now this, when we square, we get it as 1.3195. 1.3195. So x naught, it is 197.93. Therefore x naught is equal to 197.93 mg. So the dose of propofol that should be injected to induce unconsciousness in a 50 kg adult for a 2 hours operation is 197.93 mg. So here the remaining steps and the final answer will carry 1 mark. So deriving the model carries 2 marks, finding a relation for k carries 1 mark, the remaining steps and the final answer carries 1 mark. A total of 4 marks for this question. Now moving on to this year's the questions on integration and differential equations from this year's sample question paper. In the given figure, the area bounded by the curve x is equal to f of y, y-axis and abscissa are y equal to a, y equal to b is equal to. Now we have seen that we can find the value of the definite integral as area under the curve. So if you want to find the area under this curve, here we will have this as f of x and here we have 0 a. So this is nothing but integral 0 to a f of x dx. Now since usually the area is positive, we calculate the modulus of this function. Now here we have a curve as f of x. Here we have a curve which is x is equal to a function of y. As a result, the area under this curve, it is nothing but it is integral a to b. Integral a to b mod f of y dy. So the correct option is option C. Next question, general solution of differential equation y log y dx minus x dy equal to 0 is. So we have to find the general solution of this differential equation. So this y log y dx minus x dy equal to 0, it can be written as minus x dy equal to minus y log y dx. So here minus minus will go. From this we get dy by y log y equal to dx by x. So for this part alone we can do integration by substitution. Let us integrate both sides. From this we get integral dy by y log y equal to dx by x. Put t equal to log y, dt will be dy by y. So from this we get dt by t equal to integral dx by x. Or we have log mod t equal to log mod x plus log c. We can also write log mod c because we do not have log of negative numbers. So we have taken t as log y, that we can substitute here. So it is log of log y. The value of log y is going to be positive, so it is not necessary to have a modulus sign here. This is equal to, this is of the form log a plus log b, so it is log a into b. So it is log mod x into c. So if we raise both sides to the power e, we will get log y is equal to mod cx. Now log y, it is to the base e. As a result, we have y equal to e raised to mod cx. So the correct option is option B. This is the general solution of this given differential equation. Next question, evaluate integral dx upon 1 plus x into 1 plus e raised to minus x. So here for this question we have to use integration by substitution. Let us take the given integral as let I equal to integral dx upon 1 plus e raised to x into this 1 plus e raised to minus x. We can write it as 1 plus 1 by e raised to x. So if we take LCM, it is dx upon 1 plus e raised to x into e raised to x plus 1 by e raised to x. So this becomes integral e raised to x by 1 plus e raised to x the whole square dx. This is 1 plus e raised to x into 1 plus e raised to x, which is 1 plus e raised to x the whole square. This whole thing by e raised to x, when it goes to the numerator, it becomes e raised to x into dx. Now we can make substitution, put t equal to 1 plus e raised to x. As a result, we get dt equal to e raised to x dx. So the given integral becomes integral dt by t square. Now we know what is integral x raised to n dx. It is x raised to n plus 1 by n plus 1 plus c. Now this is integral t raised to minus 2 dt. It is t raised to minus 2 plus 1 by minus 2 plus 1 plus c. So it is minus 1 by t plus c. T we have taken as 1 plus e raised to x. So this is minus 1 by 1 plus e raised to x plus c. So this is the integral of this function. Next question, evaluate integral x into log of 1 plus x square dx. And this question is also given in the CBSE Handbook in the exercise under integration by parts. So let us take, let the given integral be, let I equal to integral x into log of 1 plus x square dx. Here first let us make the substitution, put t equal to 1 plus x square, so that we have dt equal to 2x dx or dt by 2 equal to x dx. So for x dx we can put half dt, and for 1 plus x square we can use t. Therefore the given integral becomes I equal to half integral log t dt. And now we can use integration by parts. Let us take this log t as the first function and 1 as the second function. Using integration by parts, the given integral becomes half into first function into integral of the second function minus integral derivative of the first function integral of the second function dt plus c. So I is equal to half into integral dt is t, so it is t log t minus integral dt is t, so it is 1 by t into t dt plus c. So t and t will go. So this is half of t log t minus integral dt is t plus c. T we have taken as 1 plus x square, that we can substitute here. So this is half of 1 plus x square into log 1 plus x square minus 1 plus x square plus c. So here 1 plus x square is common, it can be taken outside. So it is half of 1 plus x square into log of 1 plus x square minus 1 plus c. So this is the integral of this function. This question was given for 3 marks. Moving on, next question. This is also a 3-mark question. Under pure market competition scenario, the demand function PD and supply function PS are given as PD as 8 by x plus 1 minus 2 and PS is x plus 3 by 2 respectively, where P is the price and x is the quantity of the commodity. Using integrals, find the producer's surplus. So here we have to find the producer's surplus at the equilibrium price, because it is given, it is a pure market competition scenario. So under pure competition, we have PD equal to PS. The price is determined by the free forces of market supply and demand. As a result, we have PD equal to PS. From this we get 8 by x plus 1 minus 2 equal to x plus 3 by 2. Let us take LCM and simplify. So here 8 minus 2x minus 2 upon x plus 1 equal to x plus 3 by 2. So this is cross multiplying 6. 2 into 6 minus 2x equal to x plus 3 into x plus 1. So this is 12 minus 4x equal to x square plus 3x plus cx, it is 4x plus 3. Let us bring all the terms to one side. So we get x square plus 8x minus 9 equal to 0. So this is a quadratic equation in x, so it can be solved. This is x square plus 9x minus 9 equal to 0, or x into x plus 9 minus 1 into x plus 9 equal to 0. So we have x minus 1 into x plus 9 equal to 0. From this we get x is equal to 1 or x equal to minus 9. Now this is not possible since level of output cannot be negative. Therefore x naught equal to 1. From this we can substitute x naught as 1 in any of these to find P naught. So P naught is equal to 1 plus 3 by 2, which is 4 by 2, 2. Therefore x naught is 1 and P naught is 2. Now we can find the producer's surplus. Producer's surplus, it is given by P naught x naught minus integral 0 to x naught. When we are asked producer surplus, we have to consider the supply function PS into dx. So P naught is 2, x naught is 1 minus integral 0 to 1. Supply function is x plus 3 by 2 dx. So this is 2 minus half into integral x plus 3 is x plus 3 the whole square by 2 with the limits 0 to 1. So this is 2 minus, let us bring this 2 outside. So it is 2 minus 1 by 4 into, here 1 plus 3 the whole square is 4 square, 16, minus 0 plus 3 the whole square is 9. So it is 2 minus 7 by 4, which is 1 by 4. Therefore producer surplus equal to 1 by 4 units. So in this question, finding x naught carries up to this step. It carries 1.5 marks. Then writing the formula for producer surplus, the remaining steps, finding P naught, all these carries 1.5 marks. So a total of 3 marks for this question. Next question, the demand function P for maximizing a profit monopolist is given by P equal to 274 minus x square, while the marginal cost is 4 plus 3x for x units of the commodity. Using integrals, find the consumer surplus. So here the demand function for maximizing a profit monopolist is given by this function, and the marginal cost is given here. We have to find the consumer surplus. So we know that in a profit monopolist economy, we have the marginal revenue is equal to the marginal cost. So using that, we can find x naught and then P naught, and then we can find the consumer surplus. So here given demand function is P equal to 274 minus x square. So the revenue function will be R of x is equal to P into x, or it is 274x minus x cube. Here marginal cost is given, we need marginal revenue. Marginal revenue equal to R dash of x. So it is 274 minus 3x square. Therefore, marginal revenue equal to 274 minus 3x square. Marginal cost, it is given as 4 plus 3x. In a profit monopolist market, we have marginal revenue equal to marginal cost. From this we have 274 minus 3x square equal to 4 plus 3x. Let us bring all the terms to one side. If we take this to the other side, we get 3x square plus 3x minus 270 equal to 0. If we divide the entire equation by 3, we get x square plus x minus 90 equal to 0. So this is a quadratic equation in x. So we can factorize this as x plus 10 into x minus 9 equal to 0. From this we get x is equal to 9 or minus 10. Now this is not possible because we cannot have the level of output as negative. Therefore, x naught equal to 9 and P naught equal to, we can substitute in the demand function. 274 minus 9 square is 81. It is 193. Now we can find the consumer surplus. So consumer surplus is given by integral 0 to x naught, demand function dx minus P naught x naught. So here it is integral 0 to 9, demand function is 274 minus x square dx minus P naught is 193 and x naught is 9. So this, when we integrate, we get 274x minus x cube by 3 with the limits 0 to 9 minus 193 into 9, it is 1737. So here this, when we substitute the upper limit, it is 274 into 9, 2466 minus 9 cube by 3, it is 243. Lower limit is 0 minus 1737. This is 486. Therefore, consumer surplus equal to 486 units. So this is the consumer surplus. Here again, finding the value of x naught, all these steps and finding the value of x naught carries 1.5 marks. Then finding P naught, writing the formula for consumer surplus, remaining steps and the final answer carries 1.5 marks. A total of 3 marks for this question. So these are the various questions from last year's board paper, last year's sample question paper and this year's sample question paper on integration and differential equations. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. If you find this video useful, share it with your friends. Thank you for watching.